express the following in terms of ratios of acute angle, and they have given us one saying sine 150 degrees, and the second one is cos 120 degrees, and the third is tan 160 degrees. So when we are estimating angles, these angles seem to fall in the second quadrant. So the acute angle in the second quadrant was saying to be acute angle in second quadrant was 180 minus theta. So we shall bring our number one, sine 150 degrees equaling to sine into bracket 180 minus our theta here, becoming sine 30 degrees, and sine of 30 degrees is equaling to 0.5, also equaling to a half. Let's go to number 2, saying that cos 120 degrees, which will be equaling to cos into brackets 180 minus 120 degrees, becoming cos 60, and cos 60 also is the same as 0.5 equaling to a half. And let's try to go to number 3, saying tan 160 being equaling to tan 180 minus 160, becoming tan 20. Here, because it is in the second quadrant, so tan is negative in the second quadrant, becoming negative tan 20, which will be equal to negative 0.3657. So let's try to look at another confusing example. Let's try to look at another confusing example, which will say solve the following equation. When they have given us the range 0 degrees is less or equal to theta, and theta is less or equal to 360 degrees, and they have given us number 1 is cos theta equal to negative 0.5, number 2 say tan theta equaling to negative 1, and number 3 is tan theta equaling to 1. So if we go to our solution, if they said that cos theta is equal to negative 0.5, it means that theta is negative in the second quadrant and the third. So this angle here is expected to be either in the second or third quadrant, which will be cos theta equaling to negative 0.5, and theta alone, it will be cos inverse into brackets 0.5, which is a negative, becoming theta equaling to 60 degrees. But this is the acute angle which is in the first quadrant, but we know that a cos of an angle to be negative, it has either to be in the second or third quadrant. So in the second quadrant, it will be 180 minus theta, becoming 180 minus 60, becoming 120 degrees. So likewise in the third quadrant, it will be theta minus 180, becoming 60 degrees, minus 180, coming negative 120. And we know that we don't have a negative angle, so cos of a negative 0.5 is only in the second quadrant. So in the third quadrant, we have got a negative 120, and we know that we don't have a negative angle, so it means theta is 120 degrees. So let's go on number 2, which will be tan theta. Tan theta is negative 1, and we know tan theta to be negative, it's either in the second quadrant or the fourth quadrant. Coming, let's try to find the value of theta. Coming, theta becoming tan inverse negative 1, coming theta equaling to 45 degrees. But we know that tan is negative in the second and fourth, so let's go in the second quadrant, which is equaling to 180 minus theta, be equaling to 180 minus 45, coming 135 degrees. In fourth quadrant, it's 360 minus theta, equal to 360 minus 45, equaling to 315 degrees. So let's go on number 3. Which will be into tan theta equal to 1, we know that tan theta is only positive in first and third quadrant. Let's try to find the value of theta, becoming theta tan inverse 1, theta becoming 45 degrees. So theta is only positive in first and third. So this is the first quadrant, and third quadrant is theta minus 180 becoming 45 minus 180, which is a negative 135 degrees, which is impossible to have a negative angle. So it means theta is 45 degrees in the first quadrant. Let's also try to look at another confusing example. Which is given that sine A is equaling to 3/5 and is obtuse. Find the value of tan A. They have told us that sine A is equal to 3/5 and A is obtuse. So let's try to locate sine A in the Cartesian plane, which is the y-axis. So I'm carrying the x-axis, and we draw our unit circle like this. They have told us that A is obtuse, so meaning it is in the second quadrant between 90 degrees and 180. So it will be here. This is A, and sine is opposite over hypotenuse, so this one will be 3 and this one 5. So let's name this downer part x. So let's try to find x. Applying Pythagoras theorem, it will be, let me say, applying Pythagoras theorem, we shall find the value of x as 5 squared is equaling to 3 squared plus x squared, becoming 25 equal to 9 plus x squared. To get x alone to be x squared equal to 25 minus 9 x squared equaling to 16. Getting x alone, we are gonna square 16, becoming x equaling to 4. So our x is equaling to 4. And to find tan theta, we know that tan theta is equal to opposite over adjacent. So tan A will be equal to opposite, which is 3, and the adjacent, which is equal to 4. So this is the value of tan A. And a last example on quadrants will look like this. If 180 degrees is less or equal to x and x is less or equal to 360, and that cos x is equaling to negative 5 over 13, find sin x and tan x. So let's sketch our Cartesian plane like this, which is the y-axis, and this one, which is the x-axis, and we draw our unit circle. They have told us that if 180 degrees is less or equal to 360, so meaning that they are meaning this region down here, 180 and 360, this is 270 and this is 90 degrees. They want this region here, and they have given us a negative cos, meaning that negative cos is only found in the third quadrant. In the fourth, it is positive. So our point x will be here. And this is our x. So cos is adjacent, which is negative 5, over hypotenuse, which is 13, and they have told us to find sin x over sin x and tan x. So we need to find the opposite. So let's name it y, applying also Pythagoras. It will be hypotenuse, which is 13 squared, equal to adjacent, which is 5 negative 5 squared plus y squared, equal to 169.25 plus y squared, and getting y to be y squared equal to 169 minus 25, y squared equal to 144. Getting y alone be a square root of 144, y equal to 12. So y is on the negative side of y-axis, so it's gonna be also a negative 12 because it is on the negative side of y-axis. So they have told us to get sine x being equaling to opposite over hypotenuse. So our opposite is negative 12 over our hypotenuse, which is 13, and our tan x is equal to opposite over adjacent, and our opposite is negative 12 over adjacent, which is negative 5, becoming these negatives will cancel, becoming a positive 12 over a positive 5. So this is our value of tan x and the value of sin x also. Okay. After doing that, we have completed on what we call a right angled triangle. So we are going on what we call a non-right angled triangle. Non-right angled triangle. In a non-right angled triangle, there is no an angle which will be equal to 90 degrees. So by saying this, it will be like this: A, B, C. This side will reflect B. This one A, and this one also C. But these angles will be adding up to 180, but you won't find any angle inside here equaling to 90 degrees. So it may be 30 here and a 60 here. No 60. It may be like also a 30 here. So here it will be something like 120 degrees, and when you sum them up, you will get 180 degrees. So in non-right angled triangle, we are gonna look on what we call sine rule. So in non-right angled triangle, the what we call isograph and this sine ratio, cosine ratio, and also tan ratio won't work in a non-right angle. For these ones, deal only in right angled triangle. Only in right angled triangle. Apart from that, nowhere else you will use them. So in non-right angle triangle, we shall find what we call a sine rule. And this sine rule suggests like this: A over sine A equaling to B over sine B, and C equaling to sine C. i.e., if we draw our triangle like this, naming this angle A, this angle B, and this one C, this one will be A, this one will become B, and this one C. So C over sine of C, and A over sine of A, and B over sine of B. So let's try to get an example from the sine rule. It will be like given a triangle A, B, C, in which C is equaling to 4.85 centimeter, angle B equaling to 30 degrees, angle A equaling to 76 degrees, and they tell us to find angle C, and another one they tell us to find side B, another side A. If we draw our triangle like this, then this one has A, B, C. They have told us that angle B is 30 degrees and angle A is 76 degrees. So angle C is unknown, but they have given us side C, which is down here, side C, which is 4.85 centimeter. And the first question is saying to find angle C to be equaling to 76 degrees plus 30 degrees plus C equal to 180 degrees, becoming is it 70? Yeah, 76, becoming 106 degrees plus C equal to 180 degrees, C equal to 180 minus 106 degrees, C equaling to 74 degrees. So our C here is 74 degrees. They have told us to find side B, which is here, side B, and by applying sine rule, it will be like this: A over sine A equaling to B over sine B, and C equaling to sine C. So we are gonna take these two. These two here, and we become part 2 to B. B is unknown, which is B over sine 30 equal to C, which is 4.85 over the angle of C, which is sine 74. In getting B, will be going to be equaling to 4.485 times sine 30 over sine 74. B equaling to 4.85 times on what called, let me see, which is 0.5 over the sine of 75 equaling to 0.9511. B equaling to 2.7023 centimeter. So let's go to part 3 of the question to find side A. We can choose A over sine A equaling to C over sine C, whatever you want. But now we are gonna take A over sine A equaling to C over sine C equaling to A over sine 76 equaling to C, which is 4.85 over sine 74. So A will be equaling to 4.85 times sine 76 over sine 74 equaling to A 4.85 times 0.973 over 0.9511 equaling to 4.947 centimeters. So B is equal to 2.702 and A is equaling to 4.947 centimeters. So let's try to look at what we call the cosine rule. On the cosine rule, it states like that. Cosine rule states like this. That a squared is equaling to b squared plus c squared minus 2bc cos a, and b squared equaling to a squared plus c squared minus 2ac cos b, and c squared is equaling to a squared plus b squared minus 2ab cos c. So when you need to find cos a alone, it will be like cos a equaling to it will be equaling to b squared plus c squared minus a squared over 2bc. Someone there may wonder how this one comes about, but it's all algebraic format. It will be like this: a squared equaling to b squared plus c squared minus 2bc cos a. So we take the whole of this term, this side, becoming a squared plus 2bc cos a equaling to b squared plus c squared. So we take a the other side, becoming 2bc cos a equaling to b squared plus c squared minus a squared. In remaining with cos a, we are gonna divide by 2bc, and here 2bc becoming cos a equaling to b squared plus c squared minus a squared over 2bc. The same here. Getting a alone to be cos inverse into brackets b squared plus c squared minus a squared over 2bc in getting a alone. So let's look at one example from the cosine rule, and we go on what we call the area of a triangle. This example here is like this. In a triangle ABC, A is equaling to 130 degrees, B equaling to 4 centimeters, and C equaling to 5 centimeters. Find length of A. This is part 1. They have told us to find the length of A, and part 2 they are saying angle C. Part 3 saying angle B. Applying our cosine rule, we shall take the first one here, which is the first one, which will be, this is part 1, a squared equaling to b squared plus c squared minus 2bc cos a squared equaling to they have given us b equaling to 4, it is 4 squared plus c equaling to 5 minus 2 times 4 times 5 cos they have given us the angle of a equaling to 130 cos 130 degrees. So a squared will be equal to 16 plus 25, which is minus, no, it's minus 20, let me see, 2 times 4, which is 8 times, which is 40, and cos of 130 will be equal to 0.4. It is 0.6428, and when we solve it, will be a squared equaling to 16 plus 25 equaling to 41 minus 40 times 0.6428 equaling to 25.71. So a squared will be equaling to a squared, let me see, it's a negative thing. So a squared will, if we subtract, we shall get something like 41 minus 25 to 6. It will be like 5.29 by applying a square root on 5.29, it will be 2.241, which is your side. So let's try to go on part B. Let's go on part B to find angle C. Angle C. So in finding angle C, we are gonna try to use the formula here, which we are gonna apply direct and substituting A in form of C. So here it will be C, and also it will be C, and here becoming A, C, A. So it's gonna be angle C to be equaling to cos inverse into brackets, which is b squared plus a squared minus c squared over 2ab Applying the figures to be cos inverse into brackets, b is 4 squared plus a which is 2.241 squared minus c which is 5 squared over 2 times a which is 2.241 times b which is 4. Let's complete it from here. So angle C will be equaling to cos inverse into brackets 16 plus 5.29 minus 25 over 2 times 2.241 times 4 equaling to cos inverse into brackets. If we sum them up, we shall get something like we shall get something like 57.7489 over 65.36 coming a cos inverse of 0.8836, getting a 27.96 degrees. This is our angle C, and they have told us to find angle A. Angle A, we are gonna check angle B. We are not gonna waste a lot of time there. We shall use a knowledge of sum of all interior angles of a triangle add up to 180, which will be A plus B plus C is equal to 180 degrees. So A, it was 130 plus B plus C, which is 27.96 degrees, equal to 180. So it will be B plus 157.96 equal to 180. B will be equal to 180 minus 157.96. B equaling to 22.04 degrees. So after this, we are going to look on what we call the area of the triangle. Area of triangle. So let's have our triangle like this. Which is this one A, B, C. This side will reflect B, this one A and this one C. So we have our height as H, and it meets the base at point D. So from our primary, we know that area of a triangle is a half times base times height. So area is equal to a half times the base, which is C, times height, which is H. So let's name this equation 1. So let's try to consider triangle A, B, C, which is here, and let me try to sketch it. It's here like this. This is A, D, and C. This one is H, and this one is B. So here this is sine angle A. So here we can see that we have gotten what we call the opposite and the hypotenuse, and a sine ratio which deals with the opposite and the hypotenuse is the one which is called sine of theta, which is A, equaling to opposite, which is H, over the hypotenuse, which is B. On getting H alone, it will be H equaling to B sine A. Let's also try to consider triangle. Let's also try to consider a triangle DBC, which it looks like this. This part is D, and this one is B, and this one is C. So also here we have H, and this is A. So if we find sine B will be equaling to opposite, which is H, over the hypotenuse, which is A. In finding H alone, it will be A sine B. So we are going to use these different values of H here, and the same here, to substitute in the value of H in equation 1, which is to substitute in equation 1. So it will be A equaling to a half C into brackets B sine A when we substitute in the value of H, becoming area equal to a half B C sine A being equation to the same area equaling to a half AC sine B when we substitute in the value of H here, becoming AC sine B. The same also becoming area equal to a half AB sine C, as well becoming equation 4. So let's try to get an example here. Which will say in a triangle ABC, A is equaling to B and B is equaling to C and C is equaling to 10 centimeter. Find the area of triangle ABC. So let's try to sketch it like this. It will be which will be A, B, C. They said that these sides are all equal and they are equal to 10 centimeters. So it means here it will be 10 centimeter, 10 centimeter, and 10 centimeter. And a triangle which sides are equal, so it means it's called an isosceles triangle, meaning that its angles are 60 degrees because sides are the same, so angles will be 60 degrees. And they have told us to find the angle, the area of a triangle. So let's choose any of these formulas. So let's take the one here, which will be area equal to a half BC sine A, coming a half times 10 sine 60 degrees, which will be 5 times 10 and the sine of 60 is 0.866 0, getting the answer as 43.3 centimeter. So this is our area here. So let's look at what we call the Heloni's formula. Heloni's formula. It's also used to solve the area of the triangle as well. It's called Heloni's formula. So let's have our triangle like this. This one becoming A, this one B, C. So this one will reflect B, this one will reflect A, and this one C. So it states like this: area of a triangle is equaling into root S into brackets S minus A to brackets S minus B to brackets S minus C. So, and to find S is equaling to a half a perimeter of triangle ABC, which is a half into brackets A plus B plus C, which is the perimeter of the triangle. So let's try to look at an example on Heloni's formula, which we are gonna use the same example we used last time. We are not gonna change anything. So let's start by finding the value of S, which is S equaling to a half into brackets A plus B plus C, becoming S a half into brackets 10 plus 10 plus 10, becoming S into a half times 30, S becoming 15. So by applying Heloni's formula of finding the area, we shall see that A is equaling into S into S minus A into S minus B into S minus C, coming into brackets S is 15 into brackets S 15 minus A, which is 10, into brackets S is 15 also minus B, which is 10, and S is also 15 minus C, which is 10, coming 15 times 5 times 5 times 5, coming root into 1875, getting the same answer as 43.3 centimeters squared as the last, as we got last time when we used the other formula of area equaling to ABC sine A. So by doing this, we are in quotation of finding area of any triangle. And for today we are gonna set up here, and this marks the end of trigonometry, and next time we shall try to look at another topic. We shall inform you about that. So for today we have stopped here.